Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Mo's Honest Geometry class. Today we're going to wrap up Chapter 8, the Similarities and Proportions chapter. And it is a very important chapter. You're going to see this quite a bit on the SAT. So please remember all of the theorems that we will learn today and throughout this chapter. And the first theorem we're going to talk about today is one of my favorites just because it has a cool name. It's a side splitter. And side splitter states that if a line is parallel to one side of a triangle and intersects the other two sides of the triangles, then it divides those two sides proportionally. I do not want you to get mistaken with the mid-segment theorem, which is quite similar. The mid-segment theorem states that if you have a triangle and there is a segment that is connecting to the two midpoints of opposite sides of a triangle, then that segment is parallel to the base and is half the size. So if that's x, this guy would be half of x. That is called the mid-segment theorem. This is completely different. It looks the same, but it is different. I want you to very much be careful. Heed my warning there. So again, if a line is parallel to one side of a triangle and intersects the other two sides of the triangle, this shouldn't be triangles, it should be triangle, it divides those two sides proportionally. So if I tell you, I give you, that BE is parallel to CD, okay, then for sure I know that AB to BC will be proportional to AE to ED. So for example, let's say that this was true, BE is parallel to CD. I'm just putting numbers here. Let's say that's 10 and that's 8. Then that would be 5 and 4. So 10 to 8 would be equal to 5 to 4. Or, remember, the means extremes theorem, ratios theorem. I could make these proportions equal several ways. I could say 10 to 8 equals 5 to 4. Or I could say 10 to 5 equals 8 to 4. So I could go large to small from same side to large to small from the other side, or large from the opposite sides to small from the opposite sides. Does that make sense? We're good? We're good? Yes, no, maybe, kind of, sort of? Okay. Let's move on. The transversal proportions theorem. The transversal proportion theorem states this. If three or more parallel lines are intersected by two transversals, the parallel lines divide the transversals proportionately. So it's almost identical to side splitter, except in side splitter, we're talking about a triangle effect. Here in the transversal proportions theorem, which I kind of made that theorem up, it doesn't really have a name. At this point, a lot of the theorems that we learn, it's not that I make them up, I try to find the best name for them, because if not, this would be called Theorem 78. And it's kind of hard to remember theorems by numbers, in my opinion. So, if three or more parallel lines, in this case, AB is parallel to CD, which is parallel to EF, if they are intersected by two transversals, in this case, the transversals would be AE and BF, the parallel lines divide the transversals proportionately. Okay? So if this is the case, let's go ahead and, again, let's just put some random numbers. Let's put 7 and 3, and then let's make this 21 and 12. Okay? If AB is parallel to CD, which is parallel to EF, then AC to CE will equal BD to df. Bless you. Okay, it's going to cut those transversals proportionately. And please remember, we have the means extremes ratios theorem. I could go AC to CE equals BD to DF, or I could say AC to BD equals, bless you, CE to DF. Just remember to start with the same side always. So for example, if I'm going AC to CE, that's it. That side went bye-bye, but I went large to small. So now you have to set it equal to 21 to 12, large to small. If I go from large to large on opposite sides, then I have to go small to small on opposite sides, starting with the first side you started with. You could go the other way around too. Remember that as well, please. I could go 21 to 7 and then 12 to 3. So just make sure you stay linear there. Don't mix and match. What I'm saying is don't go 21 to 7 and then, oh, that equals 3 to 12. No, it does not. Okay, that would be wrong. So please be careful there. Does that make sense, gentlemen? Pretty simple, right? All right. Angle bisector theorem. Very similar to what we've just seen already. The angle bisector theorem states, if a ray bisects an angle of a triangle, and I'm sorry about this drawing, it really didn't come out to my standards. That's not a real angle bisector. Let's just assume that the drawing is an angle bisector. I couldn't get it exactly in the middle, and I apologize. But if a ray bisects an angle of a triangle, it divides the opposite side of that angle into segments that are proportional to the adjacent sides. Okay? So what's happening here? I have this ray, and it's bisecting angle BAC. So that means that BAD is congruent to CAD. We know what bisect means. But what the angle bisector theorem states is, since AD bisected BAC, let's say I put whatever, let's go 14 and 8, and then let's go, I don't know, 7 and 4. The side opposite of the angle that was bisected, that will be proportional to the adjacent sides of the triangle. So if AD does indeed bisect BAC, then BD to BA will be equal to DC to AC. Okay? And of course, I'm not going to bore you, but you have a lot of combinations there as well. Just don't mix and match them. Stay linear. So the good news is that all three of these are extremely similar. Okay, extremely similar. Just be careful. That's all. Does that make sense so far, gentlemen? I see some people writing still, no worries. Question? Okay. We're good? May I continue? All right. Let's do it then. Done. Done with theorems. Done with chapter 8 theorems. So now let's apply it. BE is parallel to CD. The lengths are as shown. I want to find ED and I want to find CD. Okay. Let's use our brain here. Let's first make this X and this guy Y, or vice versa, or whatever variables you really want to call it. Okay, it doesn't matter to me. If I know that BE is parallel to CD, then I sure as heck fire know that in order to find ED, I can set up several proportions here, guys, okay? So please choose the proportions that make sense to you. I'll do a couple of them. I could go 4 to 2 must equal 7 to Y. Has to. There's no other choice. So let's cross multiply. 4y equals 14. Y equals 3.5. 3.5. Or I could have gone 2 to 4 equals y to 7 and rendered the same answer. I could have gone 4 to 7 equals 2 to y and rendered the same answer. I could have gone 7 to 4 equals y to 2 and rendered the same answer. Make sense? Okay. Now you guys tell me, what proportion do you think I would use now, think carefully, to find x? Think carefully. Yes, sir. AC and AD to what? AC and AD doesn't do anything for me, my man. I'm sorry. Good try. Thank you for trying and caring. Sir. 2 over 4 equals 6 over... You're thinking. You're thinking, and I'm very proud of you. Think about it this way, guys, now. Don't I have this triangle here? And then don't I have this triangle here? So don't I have a large and a small triangle here? So think about it. If I go 4 to 6, that has to equal 6 to x. Do you see what I did there? I went 4 to 6 from the small triangle here. Had to equal the whole side 6 to x. Does that make sense? Okay, so now when I cross multiply and solve these, this is going to be 4x equals 36. X will equal 9. Another way to kind of see this, if it helps you, let's say I went 7 to 6 has to equal this whole side to this whole side of the large triangle. And since I know y is 3.5, it'd be 10.5 to x. A little bit of a more difficult, challenging problem there, but you're still going to have the same exact answer. Does that make sense? And actually, wait. Yeah, it will. Yeah, because that'd be 63. Yep. Does that make sense, my brothers? Talk to me. This is why I do this. You don't have to ever agree with me. Just make sure you understand. We're golden? So be careful on that one, okay? And I'm proud of you. You had the right idea. When you said AC to AD, I knew where you were going with that. Because again, he was taking the small triangle. He understood the large triangle concept, but not the small. There's a small triangle here for B, and then there's a large triangle. And I had to go small to small, large to large. Make sense, brother? Thank you, gentlemen. Awesome. You guys rule. Next. A is parallel, rather, to B, which is parallel to C, which is parallel to D. KP, the whole entire KP, read, guys. Read. KP equals 24. What is KM? Oh, that's a good one, right? Yes, sir. Please try. Let's see what you got, my brother. Okay, so first, a good start. Good start. I'm very proud of you. FJ would equal what, my brother? Excellent, okay. So now I've got that large side. Hint, hint. Go for it, my man.
Take the large side 24 and divide it by 15.
Okay, so you're going, okay. So I think I see, well, I think I see what you're saying. Okay, so he's going to go FJ, which is 15, to KP, which is 24, and he's going to set that equal to? No, dividing 24 by 15 won't do anything for you. But if you go large to large, now can't you go, that has to be the same as 5 to x? Do you see why, my man? Now, what were you going to do when you divided 24 by 15 just out of curiosity?
Now multiply it by the length.
By the length of 5?
By the length of 5. Yeah. We're looking for.
We're looking for km, right?
Yeah.
So you're making that a little bit more difficult. I see what you were going to do. You were going to do what we're doing here, but making it more confusing, okay? So think about it. I went FJ, which was 15, large, the whole side, to KP, which is 24, right? That has to be proportional to this piece to that piece. Does that make sense?
Yeah.
Give me one second. Okay, guys, sorry about that slight interruption. The question I had here was a very good one. They asked me, Mr. Morrow, you went 15 to 24, and then you went 5 to x. So you went small to large, but the question here is, how do you know that 5 is the small one as opposed to x? How do you know that 5 is smaller than x? Well, think about it. Isn't this the smaller side? Isn't 15 smaller than 24? So then all of these pieces are going to be smaller than the 15 side. Does that make sense? You promise me, my brother? So when we cross multiply here, guys, I've got 15x equals 120, which when I divide by 15, x will equal 8, right? So this, now I'll prove to you that all of these sides are larger, because I don't want you to just take my word for it. That's horrible. Let's do it again. 15 to 24, but this time let's make this y, and let's make this z. So I want to prove it to you, that if this whole side is smaller than this whole side, every piece of this side will be smaller than every piece of this right side. I want to prove that to you, though. So 15 to 24 must equal then 2 to y. 15y equals 48 divided by 15. Y would equal 3 and 1/5, which is larger than 2. And then last but not least, let's solve for z, just to prove to you. I don't want you to take my word for it. Small to large, 15 to 24 must be equal to 8 to z. 15z equals 160, 192 divided by 15. And z will equal, that's 1, and then 42 left over. It's like 12 point something. 12 point something. Just to show you that all of those will be larger. Does that answer your question, my man? Because that's a very good question. You promise? Thank you, brother. Are we good here, my brothers? So far, so good? Promise. All right? Example 3. Given that angle RVS is congruent to SVT, oh, wait a second. If that's the case, then I know that SV is an angle bisector, isn't it? Has to be. Yes, sir, my brother. Oh, okay, you got it. You want to find ST, which is X. Talk to me, my man. 8 to 4 equals 10 over X. That works perfectly. You just chose to go large to small, large to small. Fantastic. You could have also gone 4 to 8 equals X to 10. You could have also gone 8 to 10 equals 4 to X. You could have also gone 4 to X equals 10 to 8. Very well done, my brother. So 8X equals 40 divided by 8. X equals 5. Ping, pong, boom. Perfect. Yes, sir. Okay. I'm very proud of you for thinking outside the box. I'm very proud of you. The question was, if you were never told that angle RVS is congruent to SVT, his answer to his own question was, would you use the Pythagorean theorem? No. The Pythagorean theorem, remember, we haven't really gotten into it yet, but the Pythagorean theorem is only valid with right triangles. So since you don't have any right triangles here, unfortunately, you're out of luck. What I could have told you is this, or what I would have had to have told you if I didn't tell you that SV R is congruent to SVT. I could have said angle R is congruent to angle T, and angle VSR is congruent to angle VST. Then with the no choice theorem, I would have known that this guy is congruent to that guy, thereby defining that as an angle bisector. Thank you, sir. Does that make sense, gentlemen? Okay. Now, last but not least, your favorite thing in the planet, which are proofs. But hopefully you've seen that the proofs of similarity are not that crazy. Because first of all, we've been doing proofs for half a year now. And proofs should be getting better at this point. And secondly, you guys are awesome. And you know what you're doing. And thirdly, they're not that bad. So they give you that XA is parallel to YZ and that angle XAY is congruent to XYA. Here's where it gets a little tricky. They want to prove that WX to XA is proportional to WA to AZ. Okay? So that's a pretty crazy little proof there. And let me just pause here. I think I may have made a mistake. Okay, no mistake. All right, it's a little bit of a tricky proof. So let's get to it. Okay, of course, like always, my brothers, XA is parallel to YZ. So let's go ahead and label. That's given. If I know that XA is parallel to AZ, can't we use side splitter here right quick? And we can say now that WX to XY is proportional to WA to AZ. That's what I'm going to say. Does that make sense what we just did there? That's side splitter. We got plenty of time, so I don't want you to rush. Does everyone see that one? Okay, I see you guys writing because you're awesome, so I'm going to give you a second. Yes, sir. You don't see side splitter? Isn't XA parallel to YZ? So doesn't that make WX to WY proportional to WA to AZ? Remember, if this was 10 to 4 and that's 5 to 2, doesn't this to that proportional that to that? Side splitter. No, thank you. Thank you for your honesty. Okay, remember, guys, you can always put numbers in this if you wanted to, just to make your lives a little bit easier. So I know that WX to XY will be proportional to WA to AZ because of side splitter. Thanks again. If you don't see that ever, just plug in some numbers. It may make your life a little bit easier to set up these proportions. I know that it would make my life easier, so no worries. Number 3, they tell you that XAY is congruent to XAY. So XAY, this guy, is congruent to XYA, this guy. That's a given. Okay? But now here's the kicker. Here's the kicker. Think about what's parallel there. Think about those parallel and transversal angle relationships we've learned about. Yeah, you got it? You are the boss. Well, actually, no, not yet. XA is congruent to XY. Why would that be? If sides then angles. Now, what my boy had said, he said that ZYA, this guy, would have to be congruent to XAY, which would have been true. However, it wouldn't have helped you prove what we're going to prove here. Okay? So what I just did here is, if you think about what's up here, I'm taking XA and I'm saying that it's congruent to XY. This guy is congruent to this guy. Okay? So if XY is congruent to XA, then can't I replace this XY with an XA because of substitution? See what I'm doing there? This was a pretty tough proof because of that. But I'm very proud of you for what you said about alternate interior angles. It just wasn't really going to help you get to what you needed, my brother. Yes, sir, my man. Okay, thank you, sir. So you understand that the XA is congruent to XY, you promised, because of if angles then sides, right? Okay. Let's look at this first proportion we had, bro. Didn't we have WX to XY is congruent, is equal to WA to AC, right? But didn't I just say that XA is congruent to XY? So I took that XY and I replaced it with XA because of substitution. Yes, sir. You sure? Thank you, son. Does that help you, sir? Thank you. Talk to me, bro. You got it now? Thank you, my man. Anyone else? I'm very proud of you guys, as always. Okay, last but not least, brothers. This is a bit of a monster. DH is parallel to BC and HF is parallel to BG. I want to prove that CD to DE is proportional to GF to FE. So, okay. Oh, what did I do here, though? Let me copy. Sorry about that. Sorry. My bad. All right. So number one, of course, DH is parallel to BC. And that's a given. So DH is parallel to BC. Again, my drawing's a little off there. I'm going to have to work on that one. Actually, I don't like that at all. Hold on. I don't like it at all. It's going to confuse people. Let me fix this. Is that a little bit better? Yeah, it's a little bit better. A little bit better. Okay. I try. Okay. We'll make it like that. Okay. So DH is parallel to BC, given. We also, from there, not also, we can, from there, use side splitter. Remember that if this is parallel to that, then I could say that CD to DE is proportional to BH to HE because of side splitter. Then I'm going to use my next given. HF is parallel to BG. I'll do that in green. HF is parallel to BG. Okay? Since these two guys are parallel, now I can say that GF to FE is proportional to BH to HE because of side splitter. Now, pay attention to the two proportions I have. CD to DE is proportional to BH to HE. That's this guy. But isn't GF to FE also proportional to BH to HE? So can't I now say, since I have a BH to HE in both proportions, can't I say that CD to DE is proportional to GF to FE because of transitive? Remember transitive. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So here I had CD to DE is proportional to BH to HE. But then in my fourth step, I had GF to FE is also proportional to BH to HE. So since these two guys coincide, this guy can be congruent, can be proportional to that guy because of transitive property. Sir, my brother. We didn't use transitive in the previous because the proportions were not equal to the same proportional side. We replaced one segment with another segment. We substituted. Does that make sense? Thank you, my brother. We're all good here, my man? All right, brothers. Thank you as always. Hope you learned a lot and have a wonderful day. Bye-bye. Let's go.